Thank you. Can everybody see my screen and hear me?
Yes, go ahead.
Terrific. Good morning, everyone. I'll be presenting mycelium biofoam for single-use fast food packaging. Again, my name is Brooke Williams. This is a performance-based evaluation of hemp mycelium biofoam as a biodegradable alternative to expanded polystyrene. I will be referring to that as EPS for fast food packaging applications. Great. On the agenda, I'll go over introduction, problem statement, justification, research question, hypothesis, my methods, expected results, and to-date deliverables, and my plan moving forward. Let me introduce you all to the fast food packaging crisis. Annually in the US, we produce 4 million tons of fast food packaging waste, costing $9 billion annually in industrial disposal costs, with less than 10% of EPS being recycled. It also has a 500 plus year environmental persistence. 65% never gets recycled of EPS due to food contamination, making it ineligible for recycling. There's also a recovery gap. That is a material design failure, not a behavioral issue. Expanded polystyrene will never biodegrade, breaking into microplastic fragments persisting 500 plus years in our soil, waterways, and food chain. This is a problem. This is a It's a structural issue, not a behavioral issue. With them first theorizing a potential recovery of 93% and now experiencing in the actual being 29%, as well as alternatives being insufficient. Bagasse lacks insulation properties, as well as for molded pulp, lacks cushion and thermal properties for heated beverages. Recycled cardboard deforms under heat and grease, as well as BLA bioplastics require industrial composition unavailable to most consumers. This is why this research is important. The alternatives are insufficient as well as in need of a new product. So EPS is widely used for packaging, but it is petroleum-based and non-biodegradable. For those reasons, it's also becoming banned in more than 10 states in America. So I'm pushing for the alternative of hemp mycelium biofoam as a renewable. Hemp mycelium biofoam is renewable because the hemp is a fast-growing crop and mycelium is grown from fungal biomass on agricultural fibers, the hemp fibers. This research evaluates whether biofoam can match EPS performance and support sustainable packaging choices. The central research question of the study is, does hemp mycelium biofoam meet the minimum durability, heat resistance, moisture resistance, and food safety standards required for single-use fast food applications? And I hypothesize that hemp mycelium biofoam will demonstrate sufficient durability, heat resistance, moisture resistance, and biodegradability to serve as a reasonable, sustainable alternative to expanded polystyrene foam for single-use fast food packaging. So my methods is first to prepare substrate. To preparing the hemp substrate, the hemp fibers is first chopped, weighed, and measured to uniform samples. Why this is It keeps every co-inoculant sample individual, so results reflect biofoam's performance versus EPS benchmarks. The substrate will be autoclaved at 121 degrees Celsius for 30 minutes and then cooled below 30 degrees before inoculation. It is cooled so it doesn't kill the mycelium. Stage 2 is co-inoculate. Small-grain spawn from P. asperatus and G. lucidium is combined at a 50-50 ratio mixed into a cool, sterile hemp. P. asperatus colonizes very quickly, as well as G. asperatum builds dense, strong hyphae, which are the fibers in the root system of the mycelium. Combining these two captures both qualities. And then incubate and growth. Grow tents at 65% humidity for 14 days with breathable cover. A visible check, you will see visible white mycelium on all sides, shown in image C. Before removal, it'll be dried at 82 degrees C until mass is stabilized and deactivated mycelium. And that is shown in image D right here. Stage 4 is benchmark testing, where I will test the compressive strength, water absorption, biodegradability, as well as compare all of these to EPS benchmarks that I will take from a styrofoam cooler that will be tested individually and then compared to our biofoam. There'll be 10 replicants and it'll be individual t-tested at a significance level of 5%, all compared to EPS benchmarks. The expected result of this study is that hemp mycelium biofoam will be a reasonable, sustainable replacement for expanded polystyrene foam. It is expected to provide a lightweight structure, biodegradability, and reduce environmental impact for food packaging applications. Deliverables, I have an ongoing literature review. I have a lab guide as well as materials list. I have identified vendors and I'm ready to procure as soon as the university's fiscal year opens. I have also I've also drafted titles, abstracts, and other documents. These are my references that I've used to get most of my information. And that is all. Thank you so much.
Okay. Thank you, Miss Williams. I think you did a good job. I think she's just joined, so her presentation looks like she did a very good introduction. I think background studies to what she's going to do. I think it looks like she's ready to go for the mycelium research with the hemp. So hemp is one of the byproduct. Dr. I think Motley works extensively in that. They actually grow in their farm. So they have a lot of hemp waste. I think that's what I think she's going to try to do that. I think we'll have open to questions. She may not have a lot of results, but I think just any suggestions basically at this time.
So yeah, there is a company in New York area. This called Ecovative, and they make these. They use the mycelium for packaging. So you might want to go on their website and see what they are doing.
Yes, sir. Thank you.
Yeah, Ecovative.
Oh, Ecovative.
I was just curious, what part, could you specify what part of the hemp plant that you are looking to use? Because you've got both a fiber component of a bast plant, is on the outside or the bark, and then you have the woody core, which is your hemp hurd. Do you plan to use both? Do you plan to isolate the fiber and use only the fiber? Could you explain that just a little bit, what your plans are there?
Yes, sir. I'll be using the hurd, the woody core, and that is where most of the cellulose will be at, and that's what I'm trying to mainly use from the hemp. And that part will be cut into uniform pieces, and then those parts would then be mixed with the mycelium to give the mycelium its structure. So I need the most strongest part.
Okay. Just be a little bit careful there because the fiber actually has a higher cellulose content than the hurd.
Okay.
So you want to be a little bit careful with, but I see the utility in being able to control the particle size of the hurd. You can do that much easier and quicker with the hurd than you can the fiber. The fiber is kind of hard to cut, hard to manage the length.
Right.
So so just yeah, just be aware and be careful of what you're utilizing and the intended purpose for it.
Thank you so
Yeah, thank
much.
you very much thank you very much for that input because we have discussed using individual herd or bass fiber or a combination of both. So that is still a little work in progress. But thanks for that comment.
Thank you.
Yeah,
When
very
you
good job. It's a very hot area, so I think you're gonna learn a lot. And there's make sure that you do your literature review every day, read about it because there are quite a number of people working on this area right now. But it's very interesting. Good
Thank you.
job.
there are also efforts in what is called hempcrete, where
Yes.
the hemp hurds are used along with lime to make something like concrete, and there
Yes.
are houses built
Yes,
using those materials. Yeah,
yes, I've seen those hemp blocks, those mycelium blocks as well. And a lot of those research has found it very strong and durable. So I was just very interested in I've been seeing other ways that the mycelium foam has been used in like pack packaging for like packaging protection, like when you're shipping something. And so those main applications had really got me interested in how will it perform in fast food applications. Yes,
good, good.
thank
Okay.
you.
Okay.
I have a, I have a
Yes.
maybe a comment, question, observation.
Yeah.
Um, mm, do you know if those fungi form spores or something? That spores are those little seeds that when they grow, they propagate with those spores. In regular packaging, it might not be of concern, but if it comes to a food area, that may be a question. So do some literature. I don't know. I'm since I heard fungi, that's what it
Um,
just popped
yes,
in my
sir.
mind.
From my understanding, I will be doing the mycelium, which is the root system, and the fruiting body of the mycelium, which is the mushroom, and those release the spores. And I'll be capturing just the mycelium, which is the root structure underneath, and then it will be heated up to deactivate the mycelium. That's that's what I have.
Yeah, I'm glad you are aware of it and you have answers to those questions. Yeah, the fruiting bodies should not be included. Yeah,
Yes, sir.
good.
Thank you.
It's good. Thank you. So let's move on to the next presentation. Actually, we'll little